Do you ever just wonder what a shape with an infinitely long perimeter would look like? Or why things grow in a strange pattern where the smaller parts of it are like copies of itself? Fractals are rough or fragmented with self-similarity. Fractals are often seen as infinitely complex patterns, which means that you can just keep zooming and zooming and zooming in forever. Fraggles? No, fractals. And fractals are everywhere. Natural shapes and fractals were once considered outside of mathematics, as humans had a tendency to make things out of smooth, geometric shapes, while nature uses fractal patterns. Fraggle patterns? No! Fractal patterns! While these things are typically not infinite and they stop at some point, they still have many fractal qualities to them, like self-similarity. So when we're drawing a Cope curve, you would start out with a line, and then you would pull out a triangle shape out of the line, and you would try and make sure that all of these sides are similar or same size. And once you have that triangle, you would cut out another triangle, or not cut, sorry, you would pull it out. And once you have these ones, you would draw more triangles. And on those triangles, you would draw more triangles until eventually you would run out of space, because this is real life. But with today's technology, you can make an image that does go on forever. And the funny thing about a Cope snowflake or a Cope curve is that if you tried to measure the perimeter, you wouldn't be able to, because it just goes on forever and ever and ever. Julia's set is an example of a fractal that's a little bit more complex. Gaston and Julia wanted to know what would happen if you took a simple equation, put a number in it, and took your answer and put it back into the equation and just kept doing this forever in a feedback loop. Now what our main man Mandelbrot did was he took all of Julia's sets and he put them into one graph, creating this, the Mandelbrot set. So a simplified version of the equation that creates Mandelbrot set is z equals z squared plus c, where c is a complex number. That means that it just contains I, and I is the square root of -1, which is an imaginary number, which is why it's called I. If you color-coded the numbers according to how fast it grows, and if you color-coded it black if it actually turns out to be in a feedback loop and part of the set, you could get Mandelbrot set, which looks like this.